My name's Sean. I'm a PM in the Azure Compute team. I'm the product owner for Azure Container Instances. I've been spending most of the time this week at the booth and getting lots of questions about containers in general. So just as kind of a little bit of housekeeping, this session is going to assume sort of a basic familiarity with containers. So we're going to assume that you kind of know what they are, what the benefits are, how to build them. This starts from the point of you've got a container image, you've got a bunch of different ways to run it. One of the new services that we have is Container Instances. I'm going to talk a little bit about why we think that's an interesting way to run containers in Azure. But just sort of as FYI, if you're still kind of at the early stages of understanding containers, you might be not quite sure what I'm talking about in some of these cases. So what exactly is Azure Container Instances? Well, it's basically containers as a core resource in Azure, as sort of a top-level resource within the Azure resource family. And when I describe container instances that way, I typically get one of two responses. One group of people says, this is exactly what I've been waiting for, this is what I want, I have my containers, I just want to run them without anything else. This is great, when are you GAing? I have a couple of feature requests, but otherwise this is exactly what I've always wanted. The other group of people says, are you guys now going to ship a new container thing like every 2 weeks? Because I'm having a hard time keeping up. There's Azure Container Service, now there's Azure Container Instances, Service Fabric supports containers, there's App Service that supports containers. Did you really need to go ship another thing? And obviously we wouldn't be here if we didn't think so. And so the reason that we created Azure Container Instances is basically this. Today, if you think about when you've got a container image and you want to run it in the cloud, there's really no way to do that directly. The container's always sort of coming along for the ride with something else. So you think about what your options are today. You can set up a VM, install a Docker host on there, run the containers and on top of that VM, which takes a little bit of setup time, and then you've also got a VM to manage when really probably what you want to be managing is that container. You can expand out from there to set up a cluster of VMs and put an orchestrator layer on top of it. That's sort of what the Azure Container Service and Service Fabric are for. But again, you're left with a bunch of VMs to manage, there's a cost associated with having that number of VMs, which if you just need to run a handful of containers, maybe a little bit more than you want. You can also use App Service, at least on Linux today. With Linux containers, you can run those in App Service. App Service is really oriented around a specific set of application types. So if your container lines up with one of those application types, like building a web application or web service, for example, and that's a great solution. But there's a lot of cases where my container is just some sort of arbitrary application, or it runs a script, or it doesn't really align well with that service, and I don't need all the awesome stuff that I get with App Service. I just want to run containers. And so if you think about this similar to VMs, we offer a bunch of services that sit on top of VMs, but we can also just hook you up with a basic Windows Server or Ubuntu VM, and off you go, do whatever you want with it. It's completely unopinionated infrastructure in that sense. Container Instances is really that same idea, but for containers. Unopinionated, we're not optimizing for any particular scenario. You have a container, we'll run it. Sort of generic, unopinionated compute. So some of the benefits that you get with running in container instances, first of all, we think the fastest and easiest way to run a container in the public cloud, and I'll prove that in a second with a quick demo. You get out of the business of managing VMs, which can be a pro or a con, depending on what you need. So in a lot of cases, people say, look, I'm literally just building containers now and shipping those, and I don't want to deal with the underlying host, in which case getting out of the business of managing VMs is great. There's a lot of cases where it's nope, I actually need to have access to that host because I'm going to configure it in a particular way. I need to install some specific agents that are beyond the scope of the container. I need to have access to the host. In that case, using one of those VM-based solutions is going to be more appropriate. Because containers are typically application-centric and have specific sort of application-oriented requirements, we offer granular resource requests. So you can ask for the number of CPUs that you want, the amount of memory that you want, based on what that application needs, and we will bill you by the second for the running time of that container. So you can decide exactly what you need for your application, and then forever how long it runs, that's kind of what you're going to get billed for. And then naturally, we can deploy those containers from any Docker-compatible registry, whether that's Docker Hub, public or private, Azure Container Registry, or any other third-party container registry. So with that, let's jump over to a demo. Just so you can get a sense of how this looks. You guys can see that okay? So I mentioned that container instances is basically containers as a core Azure resource. So they are sort of unapologetically a part of Azure. So the way that you can interact with your containers and container instances is through all the standard Azure tools. So you're not using third-party tools or some sort of platform-specific tooling to manage your containers. You're using the Azure CLI, PowerShell, the Azure Portal, the Azure SDKs. So really, the way that you would manage your VMs, do the same thing here with containers. So I'll start in the AZ CLI and do AZ container create, give my container a name, just call it hello world. I've got a container, in this case, is up on Docker Hub that I'm going to pull down. I'm going to request a public IP address because I want to have external clients be able to access this. And then because it's an Azure resource, I'll put it in a resource group. And what this CLI command is going to do is going to fire off a request to the ACI resource provider. So again, core part of the Azure platform. So there's a resource provider behind it taking in these requests. And what I'll get back in a few seconds, network willing, is a sort of standard looking ARM JSON response. So if you're use the Azure CLI, you're probably familiar with seeing this kind of stuff. And I can do sort of the natural things like list out the containers, put them in a table, and it's already up and running. So my point about this being the fastest and easiest way to run a container in the public cloud, I think hopefully has been proven. If I go and open up a browser tab here and drop that IP in there, we should get the MSN homepage. No, there we go. Get my application. So this is a simple Node.js application packaged up in a container. Again, stored the images up in Docker Hub, and I was able to run that in Azure with no additional strings attached, no VMs. There was no sort of man behind the curtain. You can imagine I literally just signed up for my Azure account, created a resource group, and I'm running a container, and I'm going to get billed for exactly however long this runs. I mentioned that you can use all the different tools that you would expect. Actually, as of this week, we just added PowerShell support. So now I'm going to run a Windows container. So let's do that in PowerShell. So I'll go over here and do new container group, which is basically, we allow you to co-schedule a set of containers on the same host. So that's what a container group is. Oftentimes it'll just be a single container in that group, but if you have cases where you have an application container and then maybe some sort of what we refer to as a sidecar for doing logging or monitoring that needs to ride along with that container, you can put those in a group. So I'll put this, again, in that same resource group. In this case, I'll use the IIS image that Microsoft publishes. Again, I will ask for a public IP address. And I do need to list out the OS type because by default we'll expect to try to run it on Windows, and running IIS on Windows is not going to end well for anyone. Let's see, resource group. I guess I need to name it. Hello Windows. And let's run that. So I get back a more PowerShell looking response, but same kind of idea. It's now in the creating state. I've got that public IP address. You see the OS type here is Windows. The Windows containers, if anybody's been following kind of Windows Server containers, they're still a little bit large. Still working on kind of getting those getting a few pounds off of the Windows containers, so it does tend to take a little bit longer, because basically what's happening in the background here is we're going out to, in this case, Docker Hub, and pulling down that container image and starting it up on a host that we manage. And so if the container is large, it's going to take a little bit longer to do that pull. And so I think typically we're seeing somewhere on the order of like a minute startup time for Windows containers. So maybe while that's starting up, I'll show you a couple other things. One is, if I want to get some diagnostic information for these containers, oftentimes if the container doesn't start up, you might be wondering why. I can do AZ container show, put in this hello world, my resource group. And what this is going to give back to me is most of these details that I saw in the initial response to the request, but also events from what the resource provider has been doing. So if we go up here, you'll see pulling the image, successfully pulled it, and it's created and started up. So this is really useful for debugging, because 95% of the time when your container doesn't start up, it's because you fat-fingered the image name. And so if you come in here, you'll be able to see that we failed to pull that container image. Once the container's up and running, I might want to do some debugging of what's actually going on inside the container. So I can go call AZ container logs, or there's an equivalent in PowerShell, and get back basically the standard output, standard error from that container. So in this case, I'll just get the request logging from that Node.js application. So let's just see if our Windows container is up yet. Not yet, so we'll give it another second. While that's happening, I'll jump over to the portal here. And you can do the standard things that you would expect in the portal. So you can actually walk through a create workflow for your container and be able to configure it that way if you'd prefer to do that versus using the command line. You can also do management of existing running containers. It comes up. Doing cloud demos with questionable network is always fun. Go up to the resource group here. I should see my 2 containers that I've created. There we go. So I can jump in here to my hello world, and this is actually that container group concept. So again, that's kind of the actual resource, and then oftentimes under there I'll just have a single container running, but there it is running, and I can just go ahead and delete it here. And again, because I'm getting billed by the second, I was only running for whatever, a couple minutes, that's all I'll get billed for. So super useful for some of those kind of shorter running scenarios, but where you still want to have them deployed inside a container. See if our Windows container is up. Still starting. All right, we'll come back to you, Windows container. The next thing I wanted to show is oftentimes when I do this demo and show this Node.js application coming up, people go like, okay, so as I sort of referred to earlier, there's a bunch of different container options. Like, is this just another way to run web applications? So going back to the idea that this is really unopinionated infrastructure that is about generic containerized compute, you can do basically anything you can do in a container, we will run for you. So in this case, I'm going to just do kind of a simple sort of task automation scenario where I've got a container that's got a Python script in it that's going to parse through a piece of text and give us back the top words. It's going to do sort of a word counting type of process. So again, I'll do AZ container create, give it a name, call it word count, image, another image that I've got out on Docker Hub. In this case, I won't give it a public IP because I don't need external clients to be able to interact with it. It's just going to run, do its processing, and then exit. But I do need to put it in this resource group. And that's about it. So again, it's going to run what is defined by default in the container, which is to run that Python script. By default, it's going to parse the text of Hamlet and give me back the top set of words in Hamlet. And then I'll show in a second how I can go and override that default behavior with environment variables. Just talk amongst yourselves. Where is the container sitting? So it's running on VMs that we manage. Yes. Yeah, so actually I'll say a quick word about security because that's a question that comes up often. Traditionally, if you're running containers on a single host, multiple containers, they have a shared kernel, which means that they're isolated from an application perspective and application dependency perspective, but they're not truly hardened in terms of like a hostile multi-tenant kind of scenario. So here, obviously, we're running where the infrastructure is abstracted, but what we do is provide each of your container groups with hypervisor level isolation. So we're taking advantage of some of the work that's been done in Windows with Hyper-V to say that each of those container groups is actually as isolated from another container group that might be running on the same machine as if it were running inside a VM. So you don't have to worry about that, the potential for a malicious actor to break out of its container and interact with yours. Yeah, it's still lighter weight than a VM, if that's the, yeah. I don't know what's going on here. Let's try this window. Hope for better luck. Oh, it's because I've completely lost internet. Why didn't somebody tell me that? No wonder it's not working. I assume that didn't actually create. Well, hopefully in all that time, the Windows container actually started up in the cloud, and we'll be able to see it. It was all, I'm taking the hit on behalf of Windows containers. There we go. So let's do this. We're doing a little bit of multi-threading demos here. So I'm going to start this guy again. And then while that's starting up, assuming I can maintain internet, I'll grab this IP address. And it's going to be worth the wait, I tell you. You're never going to believe what you're going to see right here. Any guesses? Come on, Edge. There we go. Woohoo! IaaS, running in a container inside of Azure. How about that? All right. And, whoa, there we go. So that was I've started up our word count application. Hopefully that's now up and running. There we go. Okay, so now, what that Python script running inside that container is doing is, again, just parsing words and counting them, and then it's going to write it to standard out when it's done. So if I just do AZ container logs, word count in the resource group. There you go. There's the top 10 words in Hamlet. Now, I mentioned that's just going to run the default behavior of that container. The last thing I'm going to do, actually, yeah, I'm getting the kill sign. So let me just finish this with, I'm going to run an overridden version of that container. I'll give it a different name. Call it Macbeth. Same base image. Resource group. Again, I don't need to give it a public IP address. But what I'm going to do here is actually override a couple of the parameters. So I'm going to say, actually give me 15 words instead of 10, and then give me words that have a min length of at least 5 characters, so I don't get some of these boring words. And then I'm going to override the command line for that container, which again, it's a Python script. It's called word count. And I'm going to go ahead and grab this text. So if you're familiar with the Docker CLI, these type of commands will look pretty familiar to you. So if I go ahead and run that, again, that's just the Python script inside the container is expecting those environment variables. It has some default set, and it has a default command line set, and this way I can actually override that default behavior. Almost done. There we go, that's up and running. So now I can do logs, Macbeth, and should get back a longer list of longer words from a different play. So again, the whole point here is basically you can run the full gamut from running a web application all the way to just some sort of task automation kind of script sort of thing. Anything that's in a container, we can run for you. It's just generic, unopinionated infrastructure. So hopefully that gave you a good taste of what ACI is. I'll be around for a couple minutes to answer any questions. Thanks very much.